The domain of a function is the complete set of possible values of the independent variable. In plain English, this definition means the domain is the set of all possible x values which will make the function work, and will output real y values. The range of a function is the complete set of all possible resulting values of the dependent variable, y, usually, after we have substituted the domain. In plain English, the definition means the range is the resulting y values we get after substituting all the possible x values. A relation can be thought as a table that lists the relationship of elements to other elements. Abstractly, we define a relation to be a set of ordered pairs, such that we considered the first element of the order pair to be related to the second element of ordered pair.
Let's take a look at the example below. Suppose the weight of 4 students are shown in the following table. Student 1 with the corresponding weight of 120, Student 2 with the corresponding weight of 100, Student 3 with the corresponding weight of 150, and Student 4 with the corresponding weight of 130. The pairing of the student number and his corresponding weight is a relation and can be written as a set of ordered pair numbers. If we let R be the ordered pair of the following information from the weight of the students, the ordered pair would be: the first is 1 and 120, the second would be 2 and 100, the third would be 3 and 150, and the fourth would be 4 and 130. The set of all first elements is called the domain of the relation. And the domain of this relation is one, 2, 3, and 4. The set of second elements is called the range of the relation. The range of this relation would be 120, 100, 150, and 130. For you to mali. Next is the relation from x to y. For you to understand this topic better, let's make an example below. Consider the value for the domain are 1, 2, and 3. And the value for the range are A, B, and C. For us to know the relation from x to y, let's make an ordered pair wherein the domain would be the x and the range would be the y. If we were to make their ordered pair, it should look like this. Let A be the ordered pair. A is equals to the first of ordered pair is 1 and A. The second ordered pair would be 2 and B. The third ordered pair would be 3 and C. Given the set of values from the previous example, this time, the domain would be A, B, and C. And the range would be 1, 2, and 3. If we let A be the ordered pair again, A is equals to AN1, BN2, and CN3. Relation in A. If a set of pairs is a relation from A to A, it is said to be a relation in A. The domain and range is both equal to the subset of A. If we let X be equal to 1, 2, 3, and 4, the relation would be 1 and 1, 1 and 2, 1 and 3, 1 and 4, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 4 and 1, 4 and 2, 4 and 3, and 4 and 4. Let us take an example. If we let A be equal to Tokyo, Manila, and Beijing, and B to Japan, Philippines, and China, we can define relation as relation is equals to X and Y, wherein X is the first letter of Y, X is a member of A, and Y is a member of B. So, our relation R is shown in the diagram below. In letter A, we can put Tokyo, Manila, and Beijing. And in B, we can put Japan, Philippines, and China. This diagram represents relation with arrow, wherein it is called an arrow diagram. To properly write this relation, we write R is equals to the first set, Tokyo in Japan, Manila in Philippines, Beijing in China. The domain for this example is equal to A, wherein A is equals to Tokyo, Manila, and Beijing, and the range would be Japan, Philippines, and China. Rules for membership in the relation. A relation may be defined by given rules for membership by satisfying a given condition. The first rule is divides evenly condition. We define a relation R from X to Y by the rule XY is a member of R. If X
divides y evenly, or y divided by x remainder is equals to 0. Therefore, we obtain, if we let x be equal to 2, 3, and 4, and we let y be equal to 3, 4, 5, 6, and 7, the relation would be 2 and 4, 2 and 6, 3 and 3, 3 and 6, and 4 and 4. The domain for this relation is the set 2, 3, and 4, and the range for relation is 3, 4, and 6.
Rule number 2, and the last rule is less than or equal to condition. We define a relation R from A to A by the rule xy is a member of R if x is less than or equal to y. If we let A be equal to 1, 2, 3, therefore, we obtain relation is equals to 1 and 1, 1 and 2, 1 and 3, 2 and 2, 2 and 3, and 3 and 3. Wherein, the domain and range of the relation is both equal to the set of A.